This lesson is 7.1, Picture This, Picture Algebra. Today's learning goals are to use drawings to represent daily life situations and develop different methods to represent daily life situations mathematically. And our key term today that we're introducing is equation. So please read along with me as I read the introduction. Have you ever made a model of an airplane or a dollhouse or a car? Well, did you know that there are some people whose job it is to just create those models? It's true. These professional model builders create scale models of all sorts of buildings, bridges, parks, cars, well, almost anything you can think of. Many times, designers and architects employ model builders to create scale models from the blueprints or presentations. Why do you think scale models are helpful for presentations? Pause the video and I want you to write down a couple things that you can think of. Well, hopefully you thought of scale models show detail. It gives that 3D view instead of just a paper version. It actually shows you the 3 dimensions of what it would look like, so that if you built the car, you would actually get a feeling for the details inside of it and all around it and what it would look like in a 3D model. On the next page, let's read together this section. We're going to learn how to use pictures to represent models for equations. Number one, there are two main sections in a small town called the hill section and the lake section. The town has a population of 3,496 people. The number of people who live in the hill section is 295 more than twice the number of people who live in the lake section. How many people live in each town? So one method to solve this type of problem is to draw a picture that models the situation. In the picture, you can draw a rectangle or a box to represent an unknown quantity. And what do we call an unknown quantity? An unknown quantity is called a variable. So we're going to use a box to represent that variable. So in part A, in the situation given above, one unknown quantity is the number of people living in the lake section. Draw a box to represent the quantity and label it with a P. So let's go ahead. Under lake, we said that there is P people. They want a box. So just draw a little box and label it with a P. I don't have it on this screen, but if you look on your paper on part B and read that along with me, it says next, draw 3 boxes to represent the people who live in the hill section. Label those boxes P, P, and 295. Why do you think these boxes are labeled this way? So you should have the 3 boxes drawn below P, P, and 295 like that is. And I want you to go ahead and answer B. So under B, you should have written something of like, since there are twice as many people plus an additional 295 who live in the hill section as in the lake section, the 2 boxes labeled P, they represent twice as many, the portion, as the box labeled 295 represents 295 more than. So you should have had written something like that, since there are twice as many people plus an additional 295 who live in that hill section as in the lake section. So you should have mentioned something about why you put those 3 boxes. You have 2 of those P's plus the additional 295. So you should have written something like this. The 2 P boxes, use 2 P boxes because twice as many live there. And the 290 represents the 295 more than. So that's why we draw 2 P boxes plus an additional box that's represented by 295. All right, so in part C, this is where it's going to take you a while. So you're going to use this picture to calculate how many people live in each section of town. So you're going to need to figure out the original P in the lake section and the 2 P at 295. So let's go back and look at it. What does the whole thing add up to? That's one thing we really need to figure out. Well, we said that the whole thing, if you look up top, that town has a total population of 3,496. So we need to figure out how many is in that lake section and how many lives in that hill section. Once we know how many live in that lake section, do you think we can figure out the hill section? Well, yes, obviously, once we figure out the lake section, we know we can just figure out that hill section because we've got that p-value. And we know that it totals 3,496. So I want you to go back to question C, and you're going to pause the video. You're going to think about it. What method can you use to figure out this total? Once you've figured it out, then you can come back and look at it. But again, this might be out of your comfort zone. It's okay. Just try to think of some ways you could figure it out. Okay, so hopefully you've taken plenty of time to sit and try to figure out how many people could live in the lake section and how many people could live in the hill section. Well, if you do a lot of guessing and checking, that's probably the method you used. You could say, well, what if 1,000 people lived in a lake section? And then you'd say, well, I need 2 more of those for the hill section, so that'd be 3,000. 3,000 plus 295 is a little too less. So then you would know it's a little bit over 1,000. So you could start playing with those numbers. That's one way to solve it. And that's really the way most kids would solve it now. There is another way mathematically you could figure it out. Some of you may have already figured out that, well, I know my total is 3,496. And if I take away that amount, that 295 from the hill section, some of you might have already done that and figured out what's left over. And then seen, so if you did that, you get 3,201. Then you could say, well, I have 3 P's. Okay, well, I want to know what 1 P is. Well, how do we always figure out, we talk about unit rates and all that? Well, we would divide by however many there are there to get 1. So I would divide by 3 to get that P. So some of you figure that out. If not, it's no big deal. But in the end, you should have gotten 1,067 people. And if you go back and you say, well, to figure out hill section, if you add 1,067 plus another 1,067, and you get 2,134, and if you add another 295, you would get 2,429 people that live in the hill section. So that's how I'd figure out that 1,067 people live out in the lake section and 2,429 people live in the hill section. So let's go to the next page. Read that along with me. So you can represent the picture you drew as a mathematical sentence using operations and an equal sign. An equation is a mathematical sentence you create by placing an equal sign between 2 expressions. So one way to write an equation is to think about writing it with words. One equation you can write for the population in the small town is the number of people in the lake section plus the number of people in the hill section equals the 3,496 total population. So equation, again, is when you take 2 expressions and set them equal to each other, basically. It's when you have that equal sign. So we're going to take the picture that we drew and we're going to put it into 2 expressions, set them equal to each other to make an equation. So let's look at that. Okay, so now that you've written the situation in words, let's think about how to write it in an equation. So look at part D. First, write an expression to represent the number of people in the lake section. Let P represent the number of people in the lake section. All right, so go back to the lake section. Well, what did we have there? We already said our P, our variable P, is the number of people in the lake section. Well, that is our expression, right? It's our picture. So it would be P. Part D. Next, write an expression to represent the number of people in the hill section. Well, go back to your picture. How many P's? We have 2P, or P plus P, 2 P's, plus 295. So you could either write P plus P plus 295, because that's our picture, or you can say, well, how many P's do I have? I have 2P plus 295. Okay, 295 more than twice a number is what he's saying in the little bubble there. So that's what we're representing. All right, finally, can we write it as an equation to represent the total number? Well, remember, on the other side of our equation, we had the total. So we're trying to find the total population. If you add the lake section and the hill section together, you get that total population. So let's write that as an equation. Try to see if you can do it, and unpause the video after you're done. So hopefully you came up with the equation that I have in F. P plus 2P plus 295, so those are the two sections of town, equals our total population of 3,496. So now we're going to go through a series of some problems that do just like number one did, and I want to see more. We're going to start it out together, but I want to see if you can do it more on your own as we go through these next few problems. There's three different situations. So we're on number two. One of the farms outside of town uses a water tank for irrigation. The water tank holds a total of 5,600 gallons, and the tank has three pipes through which water drains to irrigate three different areas of the field. When water is drained from the tank, pipe B drains twice as much as pipe A. Pipe C drains 65 gallons more than pipe B. Assume that the tank is drained completely before it is refilled. How many gallons of water does each pipe drain? All right, let's first talk about what is irrigation. Now, some of you may know, but irrigation, just looking at the problem, what do you think it means? Well, it has something to do with water, because there's a water tank, and it's draining, and it's going into a field. So you probably guessed it, but irrigation is watering fields for plants. Okay, so we have the total. The water tank holds 5,600 gallons, but they have three pipes. Okay, pipe B drains twice as much as pipe A. Pipe C drains 65 gallons more than pipe B. So let's use that information to do A and A. Draw a picture to represent the water tank situation. Label the unknown parts with variables and the known parts with values. All right, so see if you can come up with it on your own, just to see if you can come up with the picture, and then start the video when you're done. All right, so if you read it through, it said pipe B drains twice as much as pipe A. So we're going to do a box if it is twice as much as A. So A is some box. We're going to just label it A. You can label it whatever variable you want. And B was twice as much, so it's going to be two of those A's. Okay. And then pipe C drains 65 gallons more than B. Well, B is two A's, so we have to draw those two A's. But it says it's 65 more gallons, so we're going to have to draw a box with 65. Okay, so we have the two A's plus that 65, because pipe C is B plus 65. And then we said the total is 5,600 gallons. So this is what your picture should look like. Okay, so in part B, it says use your pictures to determine the number of gallons of water for each pipe drain. Explain your reasoning. All right, so again, you're going to have to use some mental method to figure this out. Again, you can do some guess and check like we did in the first one. Maybe you could do something with the numbers, some operations that can help you figure out what at least one of the pipes are. So which pipe, looking at the picture, do we want to figure out first? Well, if we find out pipe A, just that one single box, then we can figure out all the rest of them. So we need to try to play with that number first. So do some mental math that you think would get you to add up to 5,600. So just think about that and come back and check your answer. Okay, again, this is the answer you should have come up with, but it might have taken a while to get there, is 1,107 for pipe A. So think about it. If you had tried 1,000, well, there's 5 A's there. So 1,000 times 5 would be 5,000 plus 65. Well, that would be 5,065. So that'd be a little too low, but you're getting close. So if you tried 1,100, you would have gotten really, really close, and then you would have probably gotten from there. Another method would be to subtract off, since you know the total of 5,600, and you know there's a 65 over on the other side. Well, if you subtract that off, you could figure that out. Okay. You could figure that out, and then, sorry, I'm not going to sit here and do all that. You could figure that out, and then take that number, and you have how many A's? You have 5 A's. Well, if you want to know what 1 A is for your unit rate, you would divide that number by 5. But again, you don't have to use that method. That's just another method that you will kind of learn later. All right, so it says write an expression in part C. Write an expression for each part. Let A represent the number of gallons drained by pipe A. Well, let's go back to our picture again. A is represented by an A. B is represented by 2 A's. C has 2 A's plus a 65. Okay, so let's go ahead and put that in. And when you're done, come back and check yourself. So here are your expressions. Now let's come up with an equation to get to that total of 5,600. All those pipes make up that tank. So pause the video and see if you can come up with the equation. So you should have come up with this question, or this equation. So can you see how pictures can help you figure out something that seems so complicated? But if you break it apart and draw it in pictures, and you can make one big equation, and then you can do some guessing and checking, at least for now, until we show you a different method, an easier method to figure it out. All right, number 3 is more of the same. So I want you to read through that. The members of a small town's local arts council are selling raffle tickets. The art council decides that the top 3 raffle ticket sellers will share a portion of the profits. The second place seller received twice as much as the third place seller. The first place seller received 20 more than the second place seller. How much will each of the top 3 sellers receive if the profit portion they will share is $200? Part A. Draw a picture to represent the art raffle situation. Label the unknown parts with variables and the known parts with values. So think about what she's saying over here in the bubble. The problem doesn't tell me anything about the third place seller. Should I start there? Think about where we started last time. It was kind of, that was usually our starting point when they didn't really tell us about something. They just put other things in terms of that. So think about that and start the video again after you have. All right, so here's what you should have come up with. It actually starts from the bottom. The third place person is obviously not going to make as much as the second place in the first place. So that's the lowest. Second place is where you take that and you double it. So if we just call it P, you can call it whatever you want. I just called it P as our variable. Third place would get some amount. Second place would get twice that amount. First place would get twice that amount, which is the second place, plus an additional $20. And all of that together would be what? Well, it says they will share $200. So all of this together will add up to $200. So that's your picture. Now you're going to come up with how much is each one using that mental math again, or whatever method you have come up with. And go ahead and do C, where you will come up with the expressions using the picture and the equation. And then, so pause the video, answer B, C, and D, and check yourself in just a second. Okay, so you should have come up with, as a final equation, 2P plus 20, that's your first place, plus 2P for your second place, plus P for your third place, and equals, they all share $200. Now we're going to do number 4 together. During the summer, Matthew and Devin started their own business mowing lawns for people in the lake section. Before starting any work, Matthew spent $15 to fill up the gas tank for the lawnmower. The boys agreed that each person would earn the same amount after Matthew was reimbursed the money he spent for gas. After a week of work, the boys were paid a total of $243. Matthew filled up the gas tank just once. How much did each boy earn? So on this one, I want you to go through and draw the picture and think about who paid for what and what they're splitting, and if they're splitting it evenly or not, to come up with your answer, your picture. Pause the video and restart it once you've come up with your picture. Okay, so this should be your picture. Matthew spent the $15, filled the gas tank. So he's going to get that money back. He's going to get reimbursed. Reimbursed means get that money back, okay, from the total that they get. So they got a total of 243, which is what's over here, but Matthew is going to get that $15 back. So he's going to get that money first before they split it. So that's why you have that extra 15 bucks. And then Devin, of course, earns whatever's left over after getting that 15, and they split it. Okay. So for B, C, and D, go through and do the equation and whatnot and your explanation of how you came up with it. Again, using your different method. So you should have, after doing whatever method you have felt that you can use, you should have gotten Matthew gets 129 because he gets that extra $15, and Devin gets 114. So your reasoning should have been they will split the money evenly after Matthew has paid his $15. So again, you should have gotten M plus 15 for Matthew. Devin gets M money, and the equation should have been M plus 15 plus M equals a total of 243. So hopefully you got out of this lesson that when you're trying to translate these words into equations, these expressions, that you can use a picture to break it apart into your knowns and your unknowns, your variables and your numbers, and what your total needs to be, what is going to be on both sides of that equation. So use that model if it works for you when you're setting up equations.